Hello everyone and welcome back to part 19 of the web development in Python with Django. PostgreSQL is an open source object-relational database management system that supports most of the SQL standards and features, including foreign keys, transactions, and etc. The database comes with many features that help developers build applications but also help administrators to protect data regardless of the dataset size. This community-driven database server is free to use, secure, reliable, and scalable. It powers dynamic websites and applications at NASA, Apple, Spotify, Reddit, and other famous companies. As programmers, we often work on different projects depending on our level of expertise. When we were in the learning stage, we worked with an application like a step-by-step tutorial that didn't need a heavy database mechanism to store task records. But as we move forward, the projects we work on change over time. We'll need to create a production-ready project requiring a database structure at some point. Typically, a primary Django project ships with an SQLite database as default. Although this is the default database, Django supports other databases such as PostgreSQL, Oracle, MySQL, and many more. So, this tutorial will focus on the Postgre and how we can implement it on Django projects. Postgre has many features that help developers build applications but also help administrators protect data, no matter how big or small dataset is. So, I'll mention several benefits of this PostgreSQL database. So first, it's free to use and an open source program, making it easy to upgrade or extend. It is not controlled by any collaboration, which means it's free to use. It supports many SQL features. Many programming languages support it, such as Python, Java, C, C++, Ruby, and etc. And Postgre is very extensible. For example, you can define data types, build your functions, or even write code using different programming languages without recompiling your database. And most importantly, it works on most popular operating systems. Up to this moment, we were using SQLite database, which was lying together with our project files. That's fine while our web server is small and doesn't have huge loads. But while our website extends, SQLite might not be the best choice. The idea here is to keep our database as separate servers. Initially, it might be running on the same machine as our Django server, but later we might get to the point where we would like to separate them. Then we can independently control the resources of our database, protected by creating a backup database or another server, and etc. There are a lot of benefits to that. So I choose to use the Ultra provider to host my PostgreSQL database. If you don't have an account here, use my referral link in the description below and you'll get a free coupon to start. So at the beginning, when you are logged in, click on this huge plus and we'll deploy a new server. In the beginning, we can choose the smallest and the cheapest option to test how everything works. So I prefer a cloud compute. Next, select your server location. And for example, it's fine to go with the AMD high performance. Right now, I'll choose Europe and I'll go with Amsterdam. I don't know why, it's only my random choice, but you can choose any location you want. As you can see, it offers a lot of them. But to choose the region closer to you is the best. So as the server image, I choose the Ubuntu and I'll choose the newest version. For a smooth beginning, starting with a 25 gigabytes NVMe drive, 1 vCPU, 1 gigabyte of memory, and 2 terabytes bandwidth is acceptable. This will cost us $6 per month. That's affordable to keep our server running 24/7. Don't choose any additional features, SSHs or firewall groups. We can do this later. So let's give it a name, and of course I'll disable auto backup. And here I'll choose a name as a Django tutorial just for now. And I click deploy now. Now I need to wait several minutes for it to complete deployment. And we can see this in our Wilter homepage. And there is the instances tab. We should see our server deployed and running after several minutes. So I pause this video and I'll come back later when it's finished. Okay, I'm back. So my server finished deploying and installing all the requirements. Let's click on it and we should see all the details. I click on Django tutorial and here's my server. So check other tabs, get familiar with options you can change by, add, or whatsoever, and etc. For now, I'll need only our IP, address, username, and password. To check the password, you need to click on this I. So simply for now, I'll need only IP address and the name of my username. Okay, I opened the terminal and let's connect to my server by issuing a SSH command. So I type SSH root and there's my IP. I write yes that I want to continue connecting. That's cool. And now I copy the password I need to connect. I issue it and we are successfully connected. So we begin by updating our server. So I type sudo apt-i update. Let's wait several minutes until it finishes. And after it's finished, we need to install the PostgreSQL core database server, command line client, and other additional dependencies. So I type sudo apt install -i SQL and contrib PostgreSQL contribution package. That's cool. Let's wait for it to complete the installation. I click OK. Everything is okay here. Now we need to verify the PostgreSQL installation. So I issue the command. Oh, sorry, I typed wrong it here. The version is 14, and this is only a specific version to this PostgreSQL version. And make sure that your output is very similar to mine. You should have PostgreSQL version 14, the newest at the point of making this tutorial. By default, PostgreSQL runs on port 5432, but we can change this if we want, but that's not necessary. So the PostgreSQL service name is given by the running PostgreSQL database server. We can manage the server by running many commands as sudo systemctl stop PostgreSQL started, restart, reload, or simply check the status. So right now we have successfully installed the PostgreSQL database server. Before we begin using it, we'll configure and secure the root user with a password in the next steps. By default, PostgreSQL ships with PSQL by default. You can use this command line client to connect to database server. The Unix user with Postgres name is also created during the installation setup. This is the super user, root user of the PostgreSQL server. To connect to the PostgreSQL server through the PSQL command line client as the Postgres user, we issue the following command. So I write sudo -u PostgreSQL, and here is PSQL. Yeah, I typed it wrong, so it's Postgres. Under the hood, this statement switches to the Postgres Unix user and runs the PSQL command. After running the command, you'll get the PostgreSQL terminal prompt. This means that your PostgreSQL is ready to accept SQL commands. When installing PostgreSQL, the root user password is not set by default. To create a password, run the following command here in Postgres terminal, and we type password Postgres. This means that I made again mistake. Here should it be Postgres. Cool. And I'll give a password to it as simply a password. Password. Now right now we need to exit the terminal by typing q command, as you can see. To test your new password, we need to edit the configuration file using nano editor. So I type sudo nano, and here is etc. Next is PostgreSQL version is 14 right now, and the main here, and here is hba.configuration. So in this file we locate for local all Postgres pair. So we scroll down here. Here it is. And here I need to change this from pair to MD5. And I click Ctrl+X plus I, enter, and then restart the PostgreSQL server. So I type sudo systemctl restart PostgreSQL. Let's wait a little while and let's try to connect to PostgreSQL server again. This time you should be asked to type your new password. So I type up. Okay, sorry, I see I made a mistake here. I changed the wrong line here in my settings. So I open it again, I scroll it somewhere here to the bottom, and I needed to change it here, MD5, and I save it. Now I need to restart our service again, and let's open our PostgreSQL terminal. And as you can see, it asks me for password, and I typed it, and we are in. That's cool. After password protecting our PostgreSQL server, we can now create a sample dataset and perform some data processing on it. But now we cannot access our PostgreSQL database from the local computer. To do so, modify the PostgreSQL configuration file to allow remote connections to the remote server. To do so, I exit this terminal. Oh, sorry. And here I type up. And here I need to navigate to PostgreSQL configuration. And here I need to find a line listing addresses somewhere. Here it is, listen addresses. And I need to change this to listen for all the addresses, not simply a localhost. I save it, I press yes, okay. And now I need to allow any user to access the database to our remote server with a password from any machine. To do so, I open my previous settings, and here I need to change host all. Here I need to change this IP to have zeros instead of localhost. Oh no, sorry, I scrolled back. Okay, I told you wrong thing. I need to scroll down. Here is host all, and here I need to change this. 0. Here is also 0, and here will be 0. And here, instead of scram shay, it will be MD5. MD5, and let me replace this line where it was localhost. That's cool. As you can see, it's IPv4 local connections. That's cool. Let's save it. And now let's restart our PostgreSQL server. Like that. So right now, the security is critical when using your virtual private server. We want to be sure that only authorized users can access our server, configuration, applications, and services. This helps protect against not only hacking attempts but also program vulnerabilities. Ubuntu has a default firewall pre-installed on your server called Simple Firewall. As the name suggests, UFW is a reasonably simple firewall that can protect your server from the most common attacks related to server port and services. It's easy to use, great at filtering server traffic, and user-friendly. By default, UFW is installed but disabled in Ubuntu, and you must enable it before opening any server ports. But in case, you can manually install UFW by running the following command. I type sudo apt-get install UFW, but as you can see, it's already installed. So I need to sudo ufb enable, yes, enable it. And now I need to allow the PostgreSQL port. So I type 5432, and here is TCP. To protect our server from unwanted access, I recommend configuring a firewall on our Vultr server. So I go to my Vultr, here is our products. I go to my original firewall settings, and here I press add firewall group. So I type it Django tutorial for now. I'll add it, and here is an SSH, so it shouldn't be anywhere. We would like it to be our IP. So I add this firewall, and also we want to add the PostgreSQL port and not but my IP. This way we'll protect our SSH and will disable connections from different IPs. So if you are developing from different computers or different locations, make sure to add more these users with different IPs. And that's it. So I press back, I go to my instances, and here is Django tutorial. I click on it, and here is our settings, and here is a firewall. I press it Django tutorial firewall, and I update the firewall group. So it might take 2 minutes to make changes, but the changes are applied immediately. So if I open my terminal, I shouldn't be disconnected. So right now we can see that we are enabled on the 2 ports, it's 22 and our Postgre port 5432 TCP. That's cool, we configured our server. Now we need to create our database. So I open my PostgreSQL terminal. My password, I log in, and here I create a database, and I'll call it test database. And we can list these databases by following command. It wasn't created. Oh yeah. Okay, I'm not sure what was wrong here, but right now it seems we created it successfully. And let's list our database, and as you can see, it was created here. That's cool. That's what we actually wanted. So now we have test database, and it's listed here. Now you can create, edit, update, or modify your database from the terminal, but this is not the tutorial's goal. So I'll continue with the important stuff. At this point, we finally prepared a remote server together with PostgreSQL database for Django connections. So let's go back to my Django code here. I open a new terminal, I close the server. As you can see, it worked before. So in the first step, we'll need to create a backup of our current SQLite database, which we will export into PostgreSQL later. To back up the data, we use the following command. So I issue the python -x utf8, and here is a manage p, manage by dump data, and I type data JSON. Everything worked, and if I open this data JSON, everything looks just fine, and this means that this is our database in JSON. You might also try to run this without this -x utf8, but if you have special characters in your database, you might fail to export the database. This way everything works smoothly. So this operation will generate as JSON file in the root of our project, which means that we have generated output data from SQLite and save it into JSON format. So before changing configurations, let's check our connection with the current database. So there is a special command that I type python manage py check, and this database and default. As you can see, everything is fine. So now we can move to another step. So let's go to my Django website settings here, and let's modify it from this database to this one. And I need to type a host port for my database. It's a test database, Postgres user, password, and let's go grab the IP of our server. It's here, I click it. It's as simple as this to change from SQLite to database. But before doing anything else, we need to make sure that our connection works. Oh, I see. So we need to install this psycop2 package. So I grab it, I type pip install, and I'll add this to requirements, not to forget this in the future. I go back to the settings and let's issue this command again and let's check the connection to our database. As you can see, everything worked just fine. And if I'll try to change something in IP, it shouldn't work. Save it. Okay. And no, okay, I'll change this 4 to 5, save, and try to connect. And as you can see, it doesn't work. So if it doesn't work, it means you missed to do some configurations on your server side, either in a Vultr front page or directly in your Ubuntu server. So for me, everything works just fine. So this means I have an open connection to my database. So simply here is nothing to explain. So after making sure that everything works for us, we can try to synchronize the database. So I type a command python manage.py and migrate, and there is a sync database command. Oh, I forgot run sync db. That's cool. It is synchronizing. And let's wait for it to finish. Cool, it's somewhere here. And now I need to open my shell. I opened it, and I need to do several stuff too. So from Django, contrib content types models, import content type. It worked. So now I need to type content type objects.all delete. Okay, I forgot a dot here. We deleted. Okay, we can quit now. Quit. And finally, we now can load our JSON file. So I type python manage.py load data, and is data.json. This should load all serialized data into the remote database with all the tables, users, fields, and etc. As you can see, it installed 84 objects from one fixture. That's nice. Now let's run our server and check whether everything works like before. So I type python manage.py run server, and I go back to my website. Here I go to my home page, and as you can see, everything works exactly the same. I can log out, I can log in, and to the same admin user, and nothing changed. It should work. That's cool. That's amazing. That's exactly what I was trying to do. And now we can delete our database SQLite free file. Okay, let's do this. Let's do this, and I'll prove you that we are not using this anymore. Move to recycle bin. Cool. I can stop the server, run it again, and you'll see that we are running this from our remote SQLite database server. And if I open it, I refresh it, everything works just like before, and we don't have local database. That's very easy, very straightforward tutorial. We successfully managed to migrate our database from SQLite 3 to PostgreSQL by executing commands successfully. That's amazing! So in this tutorial, we have followed my step-by-step install and configure SQL as backend database for a Django project. Now you can follow everything by step-by-step, either in this video tutorial or in my text version tutorial. It's up to you which you want. You can start making changes on your project and start using the PostgreSQL. And now all our previous data from SQLite will get migrated into remote server. So that's cool, that's amazing. If you like it, please like this video, share it, subscribe, comment if you have any questions. I'll try to answer, and I really hope that this tutorial was useful to you, because I saw that on internet it's pretty hard to find step-by-step explanation how to do everything clearly. So I tried to make this only for you so you could benefit from this tutorial video. So thank you again for watching. In the next tutorial, I'll cover how to deploy our Django project on the same server as our current PostgreSQL database is, and we'll have everything deployed. Maybe I'll buy some kind of domain name to make it everything as a real explanation for you. So thank you again for watching, and we'll see you in our next tutorial. See you there. Bye.